Hey everybody, welcome back. We are going to be talking about chapter 5.2. We're going to be proving triangles are congruent using two different theorems, the SSS and SAS, standing for side, 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 and the side, angle, side theorems. Okay, we are going to be doing a few two-column proofs as well. A lot of this is going to be different arguments. How can you prove triangles are congruent? Okay, and let's get down to it. Okay, we're going to be showing triangles are congruent using the SSS and SAS theorem. It says, do not have to write this down, the property of triangle rigidity gives you a shortcut for proving two triangles are congruent. It states that if the side lengths of a triangle are given, the triangle can have only one shape. Okay, that gives you the side lengths. All right, that is just triangle rigidity, just kind of, I want you to know about it. You won't be tested on it, but just have an open mind to what that is. Okay, please write this down. You only need to write the bottom piece. Don't worry about the top. Just write that bottom about the side, side, side angle, side, side, side congruence. So please write that down and I will explain. It says, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Okay, so if you know that three sides of one triangle are congruent to three sides of another, that both triangles are all together congruent to each other, which means all the sides are congruent to each other, and then the angles would be congruent to each other as well. So all you would have to do to prove two triangles are congruent is to prove that all the sides are also congruent. Okay, you need to be careful. Again, just like 5.1, watch your congruent statements. Make sure that they are properly ordered to make sure that you're properly identifying the sides that are congruent to each side and angles that are congruent to each angle. Okay. It says adjacent triangles share a side, so you can apply the reflexive property to get a pair of congruent parts. So this says an included angle is an angle formed by two adjacent sides of a polygon. Angle B is the included angle between sides AB and BC. So if you have your included angle, if you know what that is, that will lead us to the side angle side property. So B would be the angle that is included because if you notice AB and BC, where they come to a point, which is at point B, that means angle B is your included angle. Okay, which leads us into the side angle side congruence property. Please write this down again. Write the postulate and the conclusion along with the hypothesis as well. So please do that now. This states, if two sides and the included angle, that is very, very important, the included angle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So if the first property says if three sides were congruent to three sides of another triangle, they are congruent. This one, if two sides are congruent with the included included angle, that means that they are also congruent. So there's two different properties that we talked about. There's a lot of congruent. The word congruent is thrown out there a lot. Just looking at these pictures, just know where those two sides come to a point. Okay, so looking at AC and AB, where they come to a point, that common point, that is your included angle. All right, so we're going to get into this, into two-column proofs, and I want you to be able to use that as an argument to prove two triangles are congruent. Okay, don't have to write this down, but pay attention because it is very, very important. You will be using a lot of previous properties, a lot of previous postulates, previous theorems that we have talked about in this class. So everything that we have learned from chapter 1 through chapter 4 and even 5.1 you will be using. Okay, so you do need to remember that. All right, so it says use side, side, side to explain why triangle ABC is congruent to triangle DBC. We're going to be using a two-column proof, okay, which means you need two columns to help prove this statement is true. And we are going to be basically giving pieces of information little by little with arguments that says why these are congruent and why that statement, triangle ABC, is congruent to triangle DBC. The very first thing is we need to write down the given information. All right, so according to this figure, I know, based on those congruent marks, that AB is congruent to side BD. Why? Because it's given. It tells me based on those congruent marks, those congruent tick marks. Okay, I know that AB is congruent to BD. I also know based on the other tick marks that AC is congruent to DC. That is also given. Okay, so I have the side or the congruent parts or the corresponding parts on the left, and I have my argument on the right. So if you notice, this will form two columns. Okay, then I know that, the other piece that I know that BC is congruent to BC. Okay, why do I know BC is congruent to BC? That is based on the reflexive property that we have learned. Okay, this is the reflexive property that we have talked about in chapter 2. We talked about the reflexive property that BC is congruent to BC. Notice that each statement on the left has an argument on the right as to why that is true. AB is congruent to BD because that's given. AC is congruent to DC because it's given. BC is congruent to BC because of the reflexive property. So if I give you all of this information, if I split that into two triangles of ABC and DBC, if I split that, I'm just going to give you a little visual here. And B, C, D. I have congruent parts now. I have all three of my sides are now congruent. So when I have all three sides are congruent, I now can safely prove that triangle ABC is congruent to triangle DBC because of the side, side, side theorem. Okay? Triangle ABC is congruent to triangle DBC because of the side, side, side theorem. I went through it through the given information. I went through an argument with BC is congruent to BC because of the reflexive property. Therefore, I know that triangle ABC is congruent to triangle DBC because all of our sides are congruent. So this is an explanation with logical arguments that give me that triangle ABC is congruent to triangle DBC. All right? I want you to try one. Okay, so looking at this figure, we want to figure out, using the side, side, side theorem, to explain why triangle ABC is congruent to triangle CDA. I want you to be able to come up with a set of logical arguments, exactly what I showed you in the previous slide. Come up with logical arguments as to why that congruent statement is true. Let's see if you can do it. All right. So, looking at this, the very first thing I want to put down is the information that I know. So I know that AB is congruent to DC. Why do I know that? Well, looking at that figure, it gives that information to me. It is given. Okay? AD is also congruent to BC. How do I know that is true? That's also given based on those congruent marks up top. Okay? Now I have to come up with my own logical argument as to how I can prove side, side, side. So I need to figure out that third side, how I can figure out that third side is congruent to the third side of the other triangle. Okay? And how I do that is, well, I'm dealing with AC and I'm dealing with AC. So I need to prove that AC is congruent to AC, which I know is true, but how do I know that is true? Well, I know that's true because of the reflexive property. Okay? That reflexive property of congruence that we learned in chapter 2. So now I have all three sides are congruent. All three sides of one triangle are congruent to all three sides of the other triangle. So I can safely presume that triangle ABC is congruent to triangle CDA because of the side, side, side theorem. All right, I just came up with logical argument as to why triangle ABC is congruent to triangle CDA. I hope you did too. All right, if you have questions on anything that goes on in this slideshow, please ask me tomorrow because this is new information. All right, so here's a new problem that you don't have to write down, but please make sure you pay attention. You're using now logical arguments to prove the side angle side is true on this congruent statement. Okay, remember, side angle side, you have two sides and the included angle congruent to two sides and the included angle of another triangle. All right, so based on the given information, what do I know? Looking at that picture, I know that AB is congruent to DB. How? It's given to me. It tells me right there with those congruent tick marks. I also know that angle ABC is congruent to angle DBC. Why? That is given. Be careful. I notice I did not use angle B because angle B can mean three different angles here. So I want to make sure that I specifically point out which angle I'm talking about. This says ABC right here. This angle is congruent to DBC, this bottom angle. Remember, if I said angle B, it can mean either one of those, or it can mean angle ABD. Okay, so I need to specifically point out which angles I'm talking about. All right, so now I have those two given information. I have an angle, I have a side, and now I want to find that other side that makes ABC and DBC the included angle, which means I am looking at side BC of one triangle and side BC of the second triangle. So looking at this, BC is congruent to BC. How do I know that? That's what you're thinking. How do I know that's true? Well, again, our friend, the reflexive property of congruence tells me that BC is congruent to BC. So now I have my side, I have the included angle, and I have another side. So I have just proved that triangle ABC is congruent to triangle DBC because of the side angle side theorem. All right? Awesome. All right, let's try one. I want you to try one on your own here. Okay, it says the diagram shows part of the support structure for a tower. Use side angle side to explain why triangle XYZ is congruent to triangle VWZ. All right, come up with a congruence, a two-column proof to prove that this is true. All right, so starting off with the given information, I know for a fact that XZ is congruent to VZ. Why? It's given. I also know that YZ is congruent to WZ. How do I know that? It's given. So I now have two sides. And what the original problem says, I want to figure out using side, angle, side. Okay, so I have these two sides congruent to these two sides. And now where they come to a point, I want to prove those angles, or that included angle, are true. Now, looking at those angles, what type of angles do we have? Do you remember what that is? Those are vertical angles. Remember those? Vertical angles. Okay, so we have angle X, Z, Y is congruent to angle V, Z, W. Okay, angle XZY is congruent to angle VZW. Why? Our vertical angles theorem. So, as you can see, we use the reflexive property from chapter 2. We used the vertical angles theorem from chapter 2. We're using these different arguments that we have learned in the past to prove a logical argument. So, triangle X, Y, Z is congruent to triangle V, W, Z, Y, the side, angle, side theorem. Hope you came up with that. We're going to try a couple more here just to really push this. This is new information. We're coming up with logical arguments, and I really want you to pick your brain as to what arguments are we using. Okay, we've talked about this a little bit. What I want you to write down is the first two sentences. Don't worry about this last sentence. You don't have to write that down. Just write the first two sentences, please, so you can understand this. We've talked about the two-column proof in this slide. It says a geometric proof begins with a given and a prove statements, which restate the hypothesis and the conclusion of a conjecture. In a two-column proof, you list the steps of the proof in the left column. Okay, you write the matching reason for each step in the right column. Don't worry about that, but I just want you to know that we are using a two-column proof here. And you list the steps of the proof in the left side. Okay, here we go. So let's try one. Please follow this and see if you're thinking. I want you to think about this. Think about a logical argument. You don't have to write this down, but see if your thinking is correct. All right, so given information, we want to prove triangle ABD is congruent to triangle CDB. You come up with your conclusion. All right, so we start with our given information. BC is congruent to AD. That's given. What else is given? BC is parallel to AD. That is also given. That will come in importance as well. So we need to make sure that everything that is important, the information that we know, is put in this two-column proof. So we need to put those two lines are parallel. And when we see that, now we know if you look at this triangle, again, we have BD is congruent to BD because of the reflexive property. We've talked about that. Now, we have two sides that are congruent. Okay, so we have BC is congruent to AD, we have BD is congruent to BD. Now, looking at this information, how can we make either the third side or that included angle congruent to each other? Well, when I look at this, I notice my two parallel lines, BC and AD. That information in step 2 right here also makes BD, if you look at it, it looks like a transversal. Remember transversals? Well, if BDs are transversal and we have BC and AD are congruent to each other, or sorry, not congruent, but those are parallel to each other, that tells me what? What does that tell me? If you look at ADB here, that is going to be congruent to CBD here. So, angle ADB is congruent to angle CBD. Do you remember why that makes it congruent? Well, with those two parallel lines and BD being a transversal, that forms our alternate interior angles theorem. Remember the alternate interior angles theorem from chapter 2 again? All of the stuff we have learned in the past is going to be relevant in this lesson or in this chapter. We're going to be using two-column proofs. Okay, so now we can prove ABD is congruent to triangle CDB because of our SAS property. All of that information leads to our SAS property. All right, let's try one. I want you to try one on your own, see how we do. It says that QP bisects RQS, angle RQS, and QR is congruent to QS. Prove the triangle RQP is congruent to triangle SQP. I want you to give this a shot, see how you come up with or see if you can come up with the correct information. All right, get through this quickly. I know that QR is congruent to QS. Why? That's given information at the top. I also need to make sure that I properly state this, that QP bisects angle RQS, because that is also given at the top, and that's important for what we later use. I also know that QP is congruent to QP because of the reflexive property again. Ooh, there's an E in there. Okay, now using that second statement that I used at QP bisects RQS, that comes into play right now because that tells me that angle RQP is congruent to angle SQP because of that's our angle bisector definition or our theorem. Okay, it tells me because of that information, what we know about angle bisectors, that it cuts that right in half. Cuts that RQP is congruent to SQP. So now I have two sides and the included angle. Triangle RQP is congruent to triangle SQP because of our SAS theorem. Awesome. Nice. Very good job. I hope you came up with that. If you have any questions, please let me know tomorrow. Any questions about a two-column proof, I will answer them. See you tomorrow. Have a good day.